Hi, everyone, and welcome to Module 6, Lesson 3, where we're going to go through a little bit more in detail of a mole-mole ratio. So we're going to look at the fourth and final conversion from moles, and that's going to be from moles to moles. We did look a little bit at mole-mole ratios within the context of the first lesson, but now we're going to expand on that. And so you can see here, we're starting off with our mole map, but our mole map is now connected. So with our mole to mole ratio, we can convert between different moles. We can connect these mole maps. I'm going to very generally fill this out. I'm not going to go into detail because you already have one and you can fill this out yourself in more detail. And this is going to be your complete one. Okay, so the thing that we're focusing on at this point is going to be converting between moles and moles. And to do that, we're going to look at the mole ratio, kind of like we did in the first thing, but we're going to get our mole ratio from our balanced equation. Okay, so now we're using our balanced equation to convert from moles to moles. So now we can see those very long four-step problems where I could go from mass of one thing in an equation to mass of another. So that would be from mass to moles to grams. So those are going to be the longest. Or I could go from mass to atoms, or I could go from molecules to volume. Okay, and I'm going to use this. So again, pause here, draw this out on a blank sheet of paper, your whole thing, fill it out in detail, not like I did here, and keep that when we're going through these problems. So we're going to start off pretty basic, and then we're going to do a problem in the homework packet because these notes aren't going to take very long. It's just going to be practice and repetition. Okay, so let's do some of these here. It says mole ratios are used to determine the amounts of reactants needed in order to produce a certain amount of product. So it says potassium reacts with water to produce potassium hydroxide and hydrogen. Whenever we're doing a stoichiometry problem, and stoichiometry problems, very important, need a balanced equation. It's crucial. So you always start by doing a balanced equation. Potassium reacts with water to produce potassium hydroxide and hydrogen. Got to be balanced. To balance it, it's going to be 2, 2, 2, 1. Okay, got to start off with a balanced equation. That's why the last module is super important. We're doing the balanced equations because it's going to build in. It's all going to build in from here on out. Everything's just building on each other. Potassium reacts with water to produce potassium hydroxide and hydrogen. Did that. How many moles of hydrogen are made with 0.04 moles of potassium? Okay, start with what I'm given, 0.04 moles of potassium. I want to know how many moles of hydrogen are made. Okay, so I can go from moles of potassium to moles of hydrogen. This step right here, when you're going from moles to moles, that is your mole ratio. And you get the coefficients from the balanced equation. 2 moles of potassium, 1 mole of hydrogen. Moles of potassium cancel, you're left with moles of hydrogen. And you're just dividing by 2. That's the most basic, mole to mole conversions. Let's do some more. How many moles of oxygen gas are needed to produce 22.39 grams of steam in the combustion of propane? Okay, again, starting with the balanced equation. Propane, C3H8. Combustion means oxygen's the reactant. Of course, in a combustion reaction of a hydrocarbon, it's always CO2 and H2O as your products. To balance it, 5, 4 here. Oh no, 3 here, sorry. I know how to count. And 4 here. All right, So let's just map out what we're doing. We're starting with grams of H2O. We want to go to moles of O2. I can't go from grams of water to moles of oxygen. I have to go to moles of water first. Remember, when you're at the mole, you can go to anything because that's like your base unit, including moles of another thing. So these are the steps we're going to take. Grams to moles, moles to moles. Boom, there's my final answer. So start with 22.39 grams H2O, 1 mole of H2O, 18.01 grams. Grams cancel, we're left with moles. I don't want moles of water, so moles of water go on the bottom. I want moles of oxygen. All right, and then again, I get that from my balanced equation. Look at the coefficients, 5 moles of oxygen, 4 moles of water. Do that math, 1.554 moles of oxygen. Again, if you need help being able to put this stuff in your calculator, please ask, and I can show the class how to do it. I have an emulator that can show you how to work it on a Casio, and I think the free trial of my TI still works, so I can show you both calculators. Okay. Next one, how many grams of ethane are needed to produce 22.39 grams of steam? Okay, same thing, different equation though. We're doing ethane. C2H6 and oxygen gives me carbon dioxide and water. To balance, 2, 7, 6 waters, 4 carbon dioxide. Same thing, I'm going to start with my 22.39 grams of H2O, 1 mole of H2O, 18.01 grams H2O. So we're going to go from moles of water, or steam in this case, to moles of ethane, C2H6. But in this case, it's asking for grams. So I have to go one more step and go from moles of ethane to grams of ethane. So we'll go back and put in our mole ratio, 6 moles of water, 2 moles of ethane, 1 mole of ethane. It's going to be 30.07 grams. That's just the molar mass. And my final answer, again, with the correct number of sig figs, 12.46 grams C2H6. So this is going from mass of one thing to mass of a different thing from our balanced equation. And that's going to be the longest conversion problem that you'd have to do, a 4-step, which you start with 3 conversions to get your final answer. Okay, we'll do one more and then we'll look in the homework packet. Ammonium nitrate decomposes to form water and dinitrogen monoxide. Okay. Oh, dinitrogen, sorry. Well, we'll just do it in order. To form water and dinitrogen monoxide. Okay, balance it, 2 there, you're good to go. So how many molecules of water are made up of 25 grams of ammonium nitrate? Sure, we can do that. We're going to go from grams to moles, moles to moles, moles to molecules in this case. 1 mole of ammonium nitrate gives me 80.05 grams. Then we're going to go from moles of ammonium nitrate to moles of H2O. For every 1 mole of ammonium nitrate, 2 moles of water, again, from the balanced equation. And then 1 mole of H2O gives me 6.02 times 10 to the 23rd molecules. I'm going to put the final answer right here. Everything cancels, grams cancel, moles cancel, moles cancel. You're left with molecules of H2O. The answer, 3.76 times 10 to the 23rd MOL apostrophe C H2O. Okay. That's that. These are the longest conversions that you're going to have to do. Okay, 4 steps. Use your mole map, have your mole map in front of you so you can go and you can follow along what steps you need to take. So we're going to go into the homework and we're going to see Module 6, Lesson 3 homework. We're going to just do number 1 from the stoichiometry conclusion questions. So it says, automotive airbags inflate when a sample of sodium nitrate, NaN3, sodium nitride, sorry, is very rapidly decomposed. What mass of NaN3 is required to produce 375 liters of nitrogen gas? First thing I need to do is, of course, write a balanced equation. Airbags inflate when NaN3 decompose very rapidly. That would turn into sodium and nitrogen gas. Balance it. That's 3, that's 2, that's 3, that's 2, and that's 2. Okay. What mass is required to produce 375 liters of nitrogen? Okay, so we'll start with 375 liters of nitrogen. We'll turn that into moles. 22.4 liters is 1 mole of a gas at STP, because we are at STP and it says it's a gas. And then we'll go, well, 1 mole of nitrogen is, let's see, 14.01 times 2, 28.02 grams. There's your setup for the first one. So that's A. B, how many sodium atoms are produced when 375 liters of nitrogen gas is produced? Okay, so now we're going to sodium atoms. So we're going to start with our 375 liters of nitrogen. We're going to say, okay, 22.4 liters is 1 mole of nitrogen. Now we're going to sodium. Okay, so from our balanced equation, for every 3 moles of nitrogen, I get 2 moles of sodium. I'm going to do my last step right over here so you can see it better. So moles of Na go on the bottom, and we're trying to figure out atoms. So that's Avogadro's number, 6.02 times 10 to the 23rd atoms of Na for every 1 mole. That's it. That's B. And then, of course, you're going to find your answer. What is the mass of the sodium atoms produced? Okay, so I'm going to do, you could take your answer for B and turn it into grams, but that would require me finding the answer, and I don't have my good calculator in front of me. So what I'm going to do is I'm just going to do the same conversion from 375 liters of nitrogen to 1 mole. That's 22.4 liters. And then I can go from moles of nitrogen to moles of sodium. And again, that's going to be 2 moles to 3 moles. And then I can just do one more step here and go from moles of sodium to the mass of sodium, which is 22.99 grams of sodium. So it works the same way. Moles cancel, you're left with grams. That's it. Just some more examples. If you have any questions, of course, please ask them in the chat or ask them at the end of class. This I do not find to be extremely difficult. You just have to do it. You have to do your homework in order to get better at this, okay? We want to really make sure we're not falling behind. We're keeping up with the work. You've got plenty of time in class in order to work on this. So please use your time wisely. Of course, if you have any issues, please let me know. I will be happy to help. And I will see you soon.